Good morning, students. In digital electronics, we have already learned that the digital circuits can be represented using a Boolean equation. So, I have considered here a Boolean equation y is equal to AB bar C plus AB bar C plus A bar B C. Okay, and have drawn a diagram for this particular response. I have considered here only a 3-input circuit and have represented it using a diagram. When I consider there are more than 3 inputs, for example 4 inputs, and I want a response, for example you consider there are 8 terms which gives us a high output. In such cases the circuit becomes more and more complex. So is there any way to get a simple circuit, okay, simplified response? One way is use the Boolean laws and theorems and try to get the simplified equation and then try to draw the diagram or implement it using the diagram. So for that we have to remember all the laws and theorems of Boolean algebra. So sometimes you might forget which is a law to be used. So is there any other method which can be used to simplify these Boolean equations? So that method what we are going to learn is called as the Karnaugh map, or in short it is called as K-map method. So what is this K-map method? How can we use that K-map method to simplify this Boolean equations? Okay, we are going to only focus on the Boolean equations which are having SOP terms, that is sum of product equations, SOP equations. So we are going to learn only SOP equations and how to solve them using K-map in today's class. K-map is basically a graphical method used to simplify the Boolean equations. So we know any variable in an equation is represented using the alphabets A, B, C, D. At the output function we write in terms of the literals or the variables. So based on the number of inputs, okay, for example if I take A and B, in this case we have 2 inputs. So based on the number of inputs we have so many min terms. So how many min terms are there? We know that it is equal to 2 power n times, where n represents the number of inputs. N represents the number of inputs. So if you have one input, then there will be 2 variables. Okay, 2 min terms possible. If there are 2 variables, there will be 4 possible min terms. So if there are 3 variables, then we will have 8 possible min terms, and if there are 4 variables, we will have 16 possible min terms, SOP terms. So K-map, I said it is a graphical method, will use boxes to represent these min terms. And these boxes are called as cells. So we need to draw the cells. How many cells to draw is dependent on the number of input variables. So if you have one variable, we will be drawing 2 cells. If you have 2 variables, we will be drawing 4 cells. If you have 3 variables, we will be drawing 8 cells, and if you have 4 variables, we will be drawing 16 cells. So how do we draw the cells, and what does that each cell corresponds to? Let me take a 2 variable K-map. So a 2 variable K-map will have basically 2 power 2, that's equal to 4 cells. So how do you draw this 4 cells? So I told it will have a box. So the box, so here we have 4 cells. So I am going to consider 2 rows and 2 columns, and we have now 4 boxes, and these 4 boxes we are calling it as 4 cells. and each box represents a minterm. So which minterm it corresponds to? For that I have to take along row and along column the input variables. So I have two variables I said, so let me consider it as A and B. So here along row wise a variable can appear in two forms, one in complemented form and one more is uncomplemented form, that is 0 and 1. Okay, 0 is the complemented form, 1 is the uncomplemented form. That means I can write here it as A bar represents 0. Okay, and one more is uncomplemented form, that is A. Same way along column wise, the first column represents 0, that is B bar, the second column represents B, that is 1. So let me now tell you what is this cell corresponds to. So this cell corresponds to the row wise variable multiplied by the column wise variable. That means the first cell if I take here is A bar B bar. So this corresponds to, this cell corresponds to A bar B bar, the minterm A bar B bar. Same way the second cell corresponds to A bar B. And here the second row, the first cell corresponds to AB bar and the last cell here corresponds to AB. So each box corresponds to the one minterm. So this is in case of two variable K map. So let's consider a three variable K map and draw how the K map graph will look like. Okay, so here since there are three variables A, B, C, okay, if I consider these are the three variables, so 2 power 3, that means we will have totally 8 cells. So how will we draw these 8 cells? There are two possible ways to draw these 8 cells. One is you take only one variable along row and two variables along column. Okay, that's the one way. And the second way is you do the opposite. You consider only one variable along column and two variable along rows. Okay, let me draw that. I'll consider first one variable along the row. So there will be two rows. One variable can take two possible states and two variables along the column. So when I take two variables, there will be 4 possible minterms. Therefore, I have to draw 4 columns. Okay, so now we count the number of cells 1, 2, 3, 4, 5, 6, 7, 8. So there will be totally 8 cells. This is one way of drawing. The second way is I will consider a long row 4 rows and along column only 2 columns. So along row the 2 variables and along column 1 variable. So this is how you can draw a 3 variable K map, totally 8 cells. Now how will we know which row and which column corresponds to what term? See, there is one thing what you have to keep in mind. Each row or each column wise, when you go to the adjacent column or to the adjacent row or from one corner to the other point, they have to follow unit distance. It should be a unit distance coding. What do you mean by unit distance coding? There should be only one bit which is going to change when you go from one to the adjacent code. Okay, row wise here we do not have any problem because it takes now only 2 possible inputs. One is A bar and one more is A. Whereas when you go to column wise, it takes 4 possible cases. What are the 4 possible cases? First thing is it can be 0, 0. So next is 0, 1, 1, 0 and 1, 1. So this is the possible input combinations. Correct, no? So how will I write here now? So the first column I will take it as 0, 0. So it is B bar, C bar. Okay. The second column, when I go, it should be only one bit which is going to change. So it can take B bar C. So here B bar remained same, only C bar changed from C bar to C. So 1 bit distance. Now what is the next column variable I am going to take? Can I write now BC bar? So if you write BC bar, we are not going to satisfy that unit distance. If you observe, when I go from this code to here, both A and B have been changed, which is not required. As I told, it has to follow that unit distance. There should be only 1 bit which is going to change. So for that reason, I cannot write here BC bar. So what I am going to do is, I will consider that 1 and 1. So when I consider 1 and 1, so C remained same, only B bar changed from B bar to B. So only 1 bit changed. So that satisfies a unit distance condition. So the next column, I have to represent it as BC. So what is the last column now represents? So that's BC bar. Now you observe, from here to here, only 1 bit changed, that is C. C changed from C to C bar. And if you come back from the last column to the first column here, you observe the last column is BC bar, the first column is B bar C bar. And if you take that 2 bits and observe, only B changed, C bar is there in that first column also. So that also satisfies our unit distance property. So whenever you represent variables in the K-map, see to it that when you go from one row or one column to the other, the adjacent, there should be unit distance maintained. So now you can write what are the each boxes corresponds to. They represent the product of the row wise variable and the column wise variable. So here this is A bar, B bar, C bar, A bar, B bar, C, A bar, BC, A bar, BC bar, A, B bar, C bar, A, B bar, C, A, BC and A, B, C bar. So you can take the same example and try to fill in this also. Here, how do you consider the rows now? We have to consider 2 variables along the rows. So I'll just represent the rows A bar, B bar, A bar, B, AB and AB bar. So along column wise you will have C bar and C. Okay, the min terms you can only try to fill in. Okay, this is how you plot a 3 variable K-map. Okay, now let's learn how to plot a 4 variable K-map. So 4 variables means 2 power 4, that's equal to 16 cells will be there now. So how do we represent the 16 cells? Okay, so along the row I am going to consider 2 variables and along column I will consider 2 variables. Okay, that's let me consider AB along row and CD along column. So there are totally 4 variables. So how do I draw the cells now? You know each variable can take 2 possible cases. So 2 variables means it can take totally 4 possible combinations. So there should be 4 rows. Okay, same way along column I am considering 2 variables. There should be 4 columns. So now we count the number of cells. So there will be totally 16 cells. So how do I write the row wise variables? So remember that unit distance should be there when you go from one to the other, that is from one row to the other row or from one column to the other column. So let me write each row represents now A bar, B bar, the second row A bar, B, third row A, B and the fourth row A, B bar. Similarly column wise C bar, D bar, C bar, D, C, D and CD bar. Okay, once you finish writing this, you know each cell represent the product of row wise and column wise variables. So can you write the products corresponding to each cells?